Welcome back to Neural Intel. We love to go deep on the latest and greatest in AI and ML research, and today we've got something really special.
Yeah, this one's a real head turner.
So today we're talking about LLMs,
LLMs, large language models,
right?
the things that power chatbots and a whole lot more these days.
But even with all the progress they've made, LLMs still kind of hit a wall when it comes to tougher tasks that need real hardcore reasoning.
Especially in software engineering.
And that's what makes this paper so interesting. It's called SWE-RL, Advancing LLM Reasoning via Reinforcement Learning on Open Software Evolution.
Fresh off the press, too, February 25th, 2025.
So basically, they're trying to make LLMs think more like software engineers.
Exactly. Instead of just spitting out code snippets, they want these models to understand the logic, the problem solving, the whole shebang.
So what's the main hurdle here? Why are LLMs struggling with this real-world software stuff?
Well, think about it. Most LLMs are trained on massive data sets of code.
Right.
Which is great for basic stuff, but it doesn't really teach them how to be a developer.
So it's like they can write sentences, but they can't tell a story.
Perfect analogy. They're missing that deep understanding of how software evolves, how to debug complex issues, how to navigate a massive code base.
And that's where SWE-RL steps in.
Right. They're using reinforcement learning, or RL, to train LLMs on a very specific type of data, open source software evolution data, specifically GitHub pull requests.
GitHub pull requests. That's interesting.
It's brilliant, actually, because pull requests capture the entire lifecycle of a software project. You see the code snapshots, the changes, the discussions, the solutions. It's like giving the LLM a backstage pass to how real software gets made.
So instead of just static code, it's learning from this dynamic back and forth between developers.
Exactly. It's seeing how humans solve problems in the real world, and then it tries to do the same thing, generating its own code changes to fix issues.
Okay, so how does it actually learn? Is there a complex reward system involved?
It's actually pretty straightforward. They use a rule-based system based on patch similarity scores.
Patch similarity scores.
Yeah, so if the model's suggested code change is very similar to the actual solution that a human developer made in the pull request, it gets a good score.
So it's learning by example, trying to mimic the experts.
Exactly, and the results are pretty remarkable.
Oh, good.
They built this model called Llama 3 SWE-RL70B based on the Llama 3 model. And get this, it achieved a 41% solve rate on SWE-bench Verified.
Whoa, 41%? That's impressive, right? I mean, for people who don't know, SWE-bench Verified is a collection of real-world GitHub issues. It's not just some toy problems.
Nope, these are the real deal. And that 41% solve rate, it's better than a lot of other open source models, and it's getting close to what some proprietary models like GPT-4o can do.
Open source catching up. That's exciting.
Really is. But you know what else is really cool?
What's that?
The researchers actually observed what they call aha moments during the training process.
Aha moments. What does that even mean for an AI?
Well, it seems like the model was hitting these roadblocks, right? And then suddenly it would shift its approach. It was like it had a breakthrough in understanding, almost like a human aha moment.
Hold on. Are you saying the model is showing signs of actual reasoning, not just pattern matching?
That's what it looks like. It was reflecting on its assumptions, trying different things, and then boom, it would zero in on the right solution.
Wow, that's pretty mind-blowing. But let's talk practicality. How well does this model actually generalize? Can it only do software engineering tasks? Or can it apply this new reasoning power to other areas too?
That's the crazy part. You ready for this?
Hit me.
Training on software engineering actually made the model better at other things too.
No way.
Yeah, things like math code generation and different languages and even general language understanding all got a boost.
So making it a better software engineer made it smarter overall.
It seems that way. It's like solving these complex engineering problems actually sharpens your mind for other challenges too.
Fascinating. So this RL approach could have a ripple effect across different areas of AI. That's a game changer.
Potentially, yeah. And they also compared this RL model to a more traditional supervised fine-tuning model, or SFT model.
Right, the old school approach.
And guess what? The RL model crushed it.
Really?
It was much better at generalizing to new problems, and it didn't suffer from the same performance drop-off on tasks outside of its training data.
Okay, so RL is potentially creating more intelligent ADD, more adaptable LLMs.
The evidence is pointing in that direction, and they also found that scaling the training process by simply increasing the number of repair samples and tests during evaluation led to huge performance jumps on SWE-bench.
More data, better results. Isn't that always the case with machine learning?
It often is, but what's interesting here is how it impacts the evaluation phase specifically. It's not just about training data, it's also about having more data to test and fine-tune the model's performance.
Got it. And finally, they also experimented with different reward functions, and they found that a continuous reward function based on patch similarity was more effective than a simple discrete reward.
Right, a continuous reward is like giving partial credit. It's not just right or wrong, it rewards the model for getting closer to the correct solution.
So it's getting more nuanced feedback, which helps it develop those complex repair capabilities.
Exactly.
Okay, so we've covered a lot of ground, the limitations of current LLMs, the innovative solution from SWE-RL, how this whole reinforcement learning thing works, and some really exciting results. But why should our listeners care about this research?
Because this is a major step towards more effective and generalizable AI problem solvers, especially for software development. Imagine AI that can not only write code, but actually understand and fix complex bugs in our software.
It would change everything.
Right, and it's happening with open source models, so it's more accessible, and we could see a wave of new AI-assisted software development tools that are more intelligent and intuitive than ever before.
And for all you techies out there, if you want to dive into the nitty-gritty details, be sure to check out the link in our bio for the full research paper and other cutting-edge AI and ML research. But now let's take a closer look at those fascinating aha moments we were talking about.
Yeah, these aha moments, I mean, they really point to something potentially groundbreaking in how we think about AI learning. Maybe it's not just about memorizing patterns, but about genuine insight emerging.
It's a pretty wild idea.
Yeah.
Do you have an example of what one of these aha moments look like?
Sure. So picture this. The model's wrestling with this bug that involves a bunch of different components, really tricky stuff, and at first it's just hitting dead ends.
Like it's stuck in a rut.
Exactly. And then after a bunch of tries, it suddenly zeroes in on this one specific part of the code that it had completely ignored before.
Interesting.
It was like a light bulb went off, a total shift in perspective.
And that led it to the solution.
Bingo, once it focused on that key section of code, it generated a fix that actually worked like it had figured out the missing piece of the puzzle.
It really does sound like genuine insight. That's incredible.
Yeah, it suggests that these models are doing more than just following patterns. They might actually be developing real problem-solving skills.
That's huge for the field of AI now. The paper also talks about how you guys compared SWE-RL to a more traditional supervised fine-tuning model, an SFT model. What did you find?
Well, the SWE-RL model consistently outperformed the SFT model, both in its ability to solve those SWE-bench problems and in generalizing to new tasks. It seems like reinforcement learning might be a more effective way to train for these complex reasoning tasks.
So why would RL be better for this kind of thing?
We think it's because RL allows for more exploration. The model gets to experiment, make mistakes, and learn from the feedback. It's not just being spoon-fed the right answer.
So it's more like how humans learn through trial and error.
Exactly. And that seems to be key for building AI that's more robust and adaptable, able to handle new situations and challenges.
And the paper also highlighted the importance of scaling this training process, right? Just increasing the number of repair samples and tests during the evaluation phase led to big performance gains.
Yeah, that's right. It's not just about having more data to train on. It's also about having more data to test and refine the model.
Makes sense. You need to challenge the model with a variety of scenarios to make sure it can actually generalize.
Absolutely. It's all about robustness and adaptability.
Now, one of the things that really caught my eye was how training on software engineering tasks actually made the model better at other seemingly unrelated tasks.
That was a surprise for us, too.
Really?
Yeah. We found that training on software engineering boosted performance on things like math code generation in different languages, even general language understanding.
That's wild. It's like training for a marathon makes you a better sprinter.
Right. It challenges our assumptions about how AI learns and generalizes. Maybe there are these underlying cognitive mechanisms that get strengthened through complex problem solving, no matter the specific domain.
That's a fascinating thought. It raises all sorts of questions about the nature of intelligence itself. But let's bring it back down to earth for a minute. How could SWE-RL be applied in the real world of software development?
Well, one exciting possibility is the development of AI-powered debugging tools. Imagine a tool that can not only tell you exactly where a bug is, but also suggest potential fixes, even for those really tough-to-find errors.
That would be a game changer for developers.
Right. It's like having a super-powered debugger that understands your code almost as well as you do. And these tools could go even further. Helping developers refactor code, optimize for performance, even identify security vulnerabilities.
Like an AI-powered code review partner constantly working in the background to improve the quality and security of your software.
Exactly. But beyond individual tools, I think SWE-RL could also lead to advancements in how we manage and collaborate on software projects as a whole.
How so?
Well, imagine an AI system that can analyze the entire code base of a large project, identify potential conflicts, dependencies, even suggest optimal workflows for teams of developers.
That'd be huge for team productivity and efficiency.
Absolutely. It could help prevent those integration headaches that often slow down big projects. And as these AI systems get even smarter, they could even start contributing to the design and architecture of software systems.
So AI wouldn't just be assisting developers, it would be actively participating in the creative process of software design.
Right. And that raises all sorts of interesting questions about the future of the software development profession. What skills will be most valuable when AI can handle a lot of the routine work?
That's a great question, and one we'll definitely explore in future episodes.
Yeah.
But for now, I want to circle back to something you mentioned earlier, this idea of AI as a partner in innovation.
Yeah.
What does that mean to you, and what are you most excited about in terms of how AI might shape the future of software development?
Well, for me, it's about amplifying human creativity and ingenuity. AI can free us from those tedious, time-consuming tasks and let us focus on the really challenging and rewarding parts of software creation. I can't wait to see what we can build when human and artificial intelligence are working together seamlessly.
That's an inspiring vision, and this research on SWE-RL is a big step towards making it real. It shows that AI can learn from human expertise, understand complex systems, and even demonstrate flashes of genuine reasoning.
It really is a testament to the incredible work of these researchers and the potential of this technology to change the world of software development.
And for our listeners who want to stay ahead of the curve in AI and ML, be sure to check out the link in our bio. You'll find the full SWE-RL paper and tons of other fascinating research papers that are shaping the future of AI.
It's an amazing time to be following this field. New discoveries are happening all the time, and the possibilities are endless.
So thanks for joining us on this deep dive into SWE-RL. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.
I think one of the most exciting things is like these AI-powered debugging tools. Imagine a tool that could not only tell you exactly where the bug is, but also like suggest fixes, even for those really complex, hard-to-find errors.
It would be a dream come true for so many developers. No more pulling your hair out, trying to track down that one elusive bug.
Right. And these tools could even go further, maybe helping developers refactor their code, optimize it for performance, even identify security vulnerabilities.
It's like having this AI guardian angel watching over your code, constantly making it better and safer.
Exactly. But, beyond just individual tools, I think SWE-RL also like change the way we manage and collaborate on projects.
Okay, how so?
Imagine an AI system that could analyze like a whole massive code base, right? And then it could identify potential conflicts or dependencies and suggest like the best workflows for teams.
That would be a game changer for productivity.
Yeah, it could help prevent all those integration issues that can really bog down big projects. And then as these AI systems get even smarter, they could even contribute to the design and architecture of software.
So AI wouldn't just be helping developers, it'd be like a co-creator.
Right. And that's kind of mind-blowing when you think about it. I mean, it raises so many questions about the future of software development itself. What skills will be most valuable in a world where AI can handle a lot of the heavy lifting?
That's a great question, and one we'll definitely be exploring more in future episodes. But for now, I want to bring it back to this idea of AI as a partner in innovation. You've mentioned that a few times. What does that really mean to you, and what are you most excited about when you think about how AI might shape the future of software development?
For me, it's all about unlocking human potential.
Hmm.
AI can free us from those boring, repetitive tasks and let us really focus on the creative side of software development. The challenging problems, the big ideas. I'm really excited to see what we can build when human and artificial intelligence are working together, side by side.
It's an inspiring vision, and this research on SWE-RL is a big step in that direction.
Yeah.
It shows us that AI can learn from human expertise and understand these really complex systems and even demonstrate real problem-solving abilities.
Absolutely. It's a testament to the incredible work being done in this field, and the potential is just enormous.
And for our listeners who are as excited about this stuff as we are, be sure to check out the link in our bio. You'll find the full SWE-RL paper there and a ton of other cutting-edge AI and ML research.
Yeah, definitely worth a read.
So thanks for joining us on this deep dive into SWE-RL. It's been a blast. And until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with AI.